All right, guys. So let's have a look at this set. This is a set of maxima minima. So let's read the set first. So one day a class of 180 students consume 342 chocolates from among the varieties A, B, C, D, and F. All right. So there are 6 varieties of chocolates: A, B, C, D, E, F, and the class has 180 students, and they consume 342 chocolates. So no student. Okay, this is a typing mistake. It's basically 8, right? It's quite obvious. So no students ate 2 chocolates of the same variety. That means if you take A, you can take only one A. If you want to take 2, you can take any other from B, C, D, E, or F, but you cannot take 2 A's, right? Okay, so the number of students who ate the varieties, this is all 8, who ate the varieties D, E, F was 73, 93, and 45. Respectively, the number of students who did not have any chocolate was equal to the number of students who either had exactly one of the chocolates or all the 6 varieties. All right. So the number of students who did not have any chocolate was equal to the total number of students. That means the sum of students who either had nothing or had all the 6 varieties. Now the following bar graph indicates the number of students who consume 2, 3, 4, and 5 varieties of chocolates. All right. So this is a basic typical question of maxima minima, and we'll follow it using the traditional approach. All right, so let's have a look at the questions first. So number of students who had exactly one variety, then we have number of students who did not have any variety. So we can go through the proper method. So let's solve it here. Okay, so now just understand the nomenclature first. So how do we represent it? N stands for number of people who did not have any variety of chocolate, right? We can call it null set. These students, N is the number of students who did not get any variety. A stands for, small a stands for students who got exactly one variety of a chocolate. Now B stands for exactly 2. It can be any of the 2, right? Exactly 1 means A stands for number of students who are getting only 1. They can be from A, B, C, D, or E, or F, and whatever brand it is. All right, and so on. So C stands for 3, D stands for 4, E stands for 5, and F stands for number of students who got all the 6 varieties. Okay. So now if we can form 2 equations, just to understand, one equation can tell us about the number of students. So N plus A plus B plus C plus D plus E plus F is equal to 180. How is it coming? I hope it's clear to everyone that N stands for number of students who got no variety of chocolates. So there will be some students here. These will be the number of students who got one variety. These will be the number of students who got 2 varieties, and all these are different from each other, right? A student who is getting 2 chocolates, exactly 2 chocolates, cannot be a student who can get exactly 3 chocolates, right? So this is the equation which can tell us about the number of students. Now we can form another equation about the number of chocolates. So of course, number of students are not getting any chocolate will not contribute to any chocolate. So we will not consider N in this case. Now, what we can consider, A will be the number of students. A is the number of students who are consuming just 1 chocolate. So let's say there are 50 students and everyone is consuming just 1 chocolate. That means 50 chocolates will be consumed, right? So and similarly, B, let's say B is the number of students who are consuming 2 chocolates. So for example, if 4 students are consuming 2 chocolates, so the total number of chocolates consumed will be 4 into 2, that will be 8. So if we have to calculate the number of chocolates, so this will be 2B. Similarly, it will be 3C. It will be 4D plus 5E plus 6F. And that will come out to be 342. Right? So now the problem is we are having so many variables in just 2 equations. Let's see if we know the value of any of these variables. So from this particular graph, we can see that the number of students who are eating 2 chocolates is 10, 3 are 12, 4 are 16, and 5 are 8. Right. Also, we know from this particular statement that the number of students who did not have any chocolate was equal to the number of students who had either exactly 1, a total of either exactly 1 or all the 6 varieties. So what does it mean? Now this particular line means that if we have to find the value of N will be equal to basically A plus F. Why? Because A is the number of students who are consuming exactly 1 chocolate, and F is the number of students who are consuming all the 6 varieties, right? So as it is written that N is equal to the total number of students who consume exactly 1 or all 6. So don't get confused by or in this, because we have already been told about the total number of students, right? So even if you're falling in this category or in this category, we have to sum it up. So now on the basis of this particular expression and the values, we can form two final equations. So this here a plus f will come 2 times, so it will become 2 times of a plus f plus, now for b we can write 10 plus 12 plus 16 plus 8 is equal to 180. Solving it further, 2 times of a plus f will be e plus, so this will be 20 plus 36 plus 10, 46. Is equal to 180. That means 2 times of a plus f will be equal to 134, and this will make a plus f equals to 67, right? So n's value will be 67. We know the value of a plus f is equal to 67, so we can form it, take it as equation 3, for example. Now solving this second equation, we putting the values of b, c, d and e, so we can get like a plus 2 times of b, that is 20, plus 3 times of b, that will be 36, plus 4 times of d, that will be 64, plus 5 times of b, that will be 40, plus 6 times of f, that will be all equal to 342. Now solving it further, a plus 6f plus, if we add it all, so 64 plus 36 will be 100 plus 60, so that is 160 is equal to 342. That means a plus 6f will be equal to 182. I hope this is clear till this point. Now we can take it as equation 4. Solving equation 3 and 4, we can get a plus f is equal to 67 and a plus 6f is equal to 182, and that means 5f will be equal to 115, and that will make f equals to 23, and a will become 44. All right, so we know the value of a and f. So the first question, the number of students who had exactly one variety. So one variety is of course a, that is equal to 44. The next question, who did not have any variety, that is the value of n, and it is of course 67. Now coming to the next question. Okay, so the number of students who had chocolates of only variety D is at least. Now we need to understand the basic concept of maximum minima here. We have to minimize the number of students who got variety only of only D. That means for D we will have 6 type of students for chocolate variety D, right? So let's call D as dairy milk to avoid the confusion. So there will be some students who will just take one of D. There will be some students who will take 2 Ds. Some who will take, sorry. So there will be some students who will be taking just one chocolate, and that will be dairy milk. That is D, right? Now there will be some students who will be taking 2 chocolates, out of which one is D and one is something else. Now there will be some students who will be taking one of 3 chocolates in all. One will be D and 2 of other varieties. Now there will be some students who will be taking 4 varieties in all, out of which one will be D and there will be 3 other varieties. Now there will be some students who will be taking 5 varieties in all, out of which one will be D and 4 other varieties. And F, who are taking every variety, so they will take 1 D and 5 other varieties. Right? Now if we have to minimize the number of students who get only D, we need to maximize D's. Now we need to consider that every student who is taking more than one chocolate is taking at least 1 D. So what we need to do, we need to calculate, we can see the total number of chocolates of variety D was 73. So for only D, what we can do? So let's take in every category, let's take every student took a D as well. So out of these 10 students who took 2 chocolates, one was of course D. Why we are doing so? Because we have to maximize this pool to minimize this. In this question, we are asked to minimize this, right? So we can subtract this 10, 12, 16, 8, and of course, who took all the varieties, that is 23. right? Okay. So adding all of them, it will come out to be 46 plus 23, that is 69. So out of these 73 chocolates, 69 chocolates are consumed by students who consume more than one chocolate. So of course there will be 73 minus 69, that will be 4 chocolates which are consumed by students who just took only D. So the minimum value of this particular question, the answer will be 4. Now moving on to the next one. So if the number of students who had chocolates of exactly 2 varieties D and F is 10, and those who had chocolates of exactly 3 varieties D, E and F is 12, then the number of students who had chocolates of only variety F, right? So from the question we can see the number of students who took variety F was 45, right? So out of this 45, now if we remember, there were 23 students who consumed all the varieties, right? So if they're consuming all the varieties, of course, they will be consuming F as well. So first we subtract this 23 from this 45 and this will come out to be 22. Okay. Now we know that number of students are consuming D and F is 10. So we subtract 10 from it again. Now this will come out to be 12. And number of students who are consuming exactly D, E and F is 12. So we remove this 12 as well and we are not left with any of the Fs now. So the number of students who had chocolates of only variety F is of course 0. Because out of all the 45 chocolates of F, 10 students consume D and F, so 10 Fs are removed. Then we know 12 students consume D, E and F. These 12 students again are removed. And those 23 students who took all the varieties, they must have taken F, so they also are to be removed. So we are left with no chocolates. So the number of students who had chocolates of only variety F is 0.